Let's dive into our next section, which focuses on cloud-based attacks, a crucial aspect of penetration testing in today's increasingly cloud-centric environment. Understanding and performing cloud-based attacks is essential because organizations continuously move their infrastructure to the cloud, which introduces new vulnerabilities and attack vectors. In this introduction to cloud-based attacks, we will discuss the various types of attacks that can be performed in a cloud environment and why, as penetration testers, you need to be proficient in identifying these threats. Moving on to the next slide, we will explore metadata service attacks. Here, we'll start by defining what a metadata service attack is and discuss its potential impact. Metadata service attacks exploit a cloud service's metadata endpoint to gather sensitive information. We'll cover techniques for performing these attacks effectively. For example, exploiting the AWS EC2 instance metadata service to retrieve IAM credentials. This can be done using a simple curl command, curl http 169.254.169.254 latest metadata/security credentials/. We'll look at how this command can be used to access critical security credentials, making it clear why protecting against these kinds of attacks is vital. On the previous slide, we introduced the concept and importance of cloud-based attacks within the scope of penetration testing. Understanding these attacks is crucial for evaluating the security posture of cloud environments. Let's dive into metadata service attacks on this slide. Metadata service attacks target the metadata service provided by cloud instances. These services offer sensitive information about the running instance, often including IAM credentials. Imagine you're working with an AWS EC2 instance. By exploiting its metadata service, you can potentially retrieve IAM credentials, which in turn can lead to further compromise of the cloud environment. A popular technique to perform such an attack involves using a simple curl command to query the metadata service. For example, to retrieve IAM credentials, you could execute curl /169.254.169.254 latest /metadata/IAM/security credentials/. This command fetches the security credentials associated with the instance, giving you access that can be leveraged for further exploitation. Let's move on to the next slide, where we'll explore identity and access management misconfigurations, another critical aspect in cloud security. Continuing from our previous discussion on metadata service attacks, let's now turn our attention to identity and access management, IAM, misconfigurations. On this slide, we'll explore what IAM misconfigurations are and the impacts they can have on your AWS environment. IAM misconfigurations can dangerously broaden the access scope of various identities, potentially allowing unauthorized actions that could lead to data breaches or service disruptions. We'll also discuss techniques for identifying and exploiting these misconfigurations. One effective tool for this purpose is Scout Suite, which automates the auditing process and helps pinpoint IAM misconfigurations. As shown in the example command, you can run Scout Suite against your AWS environment to detect these vulnerabilities. Scout AWS region US-East-1. This tool, along with the appropriate understanding of IAM policies and configurations, can greatly enhance your security posture by allowing you to promptly fix any identified misconfigurations. Next, we'll delve into the vulnerabilities associated with third-party integrations. In the previous slide, we discussed identity and access management, IAM misconfigurations. We explored the definition and impact of these misconfigurations, techniques for identifying and exploiting them, and demonstrated how to use Scout Suite to detect IAM misconfigurations in AWS. Now, let's shift our focus to third-party integrations. In this slide, we will look at the definition and impact of vulnerabilities in third-party integrations. These integrations can introduce significant risks if not properly secured. We will delve into the techniques for identifying and exploiting these vulnerabilities. One of the tools that can help with this is Prowler. Prowler is a security tool that performs AWS security assessments. To assess the security of third-party integrations, we can use a specific Prowler command, Prowler C integration checks. This command enables us to run a comprehensive scan to identify potential vulnerabilities in third-party integrations, ensuring that our overall security posture is robust. In the next slide, we will continue by discussing resource misconfigurations. We'll cover the definition and impact of these misconfigurations, techniques for identifying and exploiting them, and demonstrate how to use PACU to check for exposed storage buckets and public access. On this slide, we'll be tackling the topic of resource misconfiguration. Resource misconfiguration occurs when cloud resources are not set up or managed properly, which can lead to severe security vulnerabilities. Misconfigured resources, such as improperly set permissions or exposed storage buckets, can be detrimental. These misconfigurations can lead to unauthorized access, data breaches, and overall compromise of an organization's cloud environment. Understanding and fixing these flaws is crucial for maintaining a secure infrastructure. To identify and exploit these misconfigurations, we must use techniques like scanning for exposed resources, reviewing access controls, and checking configuration settings. In practice, tools like PACU can be instrumental. For example, using PACU to check for exposed storage buckets and public access can reveal significant security lapses. You can run the command PACU run S3 enum buckets to enumerate and evaluate the security of your S3 buckets. Next, we will delve into logging information exposure. We'll cover its definition and impact and discuss how to identify and exploit exposed logging information, with a specific focus on using CloudTrail for analyzing cloud logs for sensitive information. Continuing from where we left off with resource misconfigurations, let's move on to a critical aspect of cybersecurity in the cloud: logging information exposure. In this slide, we'll delve into what logging information exposure is and the potential impact it can have on your cloud environment. Logging information exposure occurs when sensitive information is inadvertently logged and becomes accessible to unauthorized users. This can lead to severe data breaches, as logs often contain valuable insights about system operations, user activities, and even security configurations. To identify and exploit these exposures, you need to have robust logging practices and continuous monitoring in place. One effective technique is analyzing your cloud service logs for any sensitive data inadvertently recorded. For example, incorrect logging configurations can expose API keys, user credentials, or other crucial data points. As an example, you can use tools like CloudTrail to analyze logs within your AWS environment. CloudTrail provides a history of AWS API calls made on your account, which can be scrutinized for any sensitive information that might have been logged unintentionally. By regularly auditing these logs, you can quickly spot and remediate any instances of exposed information. In the next slide, we will discuss image and artifact tampering, where we'll define the concept, understand its impact, and explore techniques for identifying and exploiting tampered images or artifacts. Specifically, we'll look at using Docker Bench to detect vulnerabilities in Docker images. On our last slide, we discussed the risks associated with logging information exposure. We defined what it is, illustrated its potential impacts, and delved into techniques for identifying and exploiting these exposures. We also looked at a practical example using CloudTrail to analyze cloud logs for sensitive information. Moving on to slide 7, we'll focus on image and artifact tampering. First, let's define what we mean by image and artifact tampering. This involves unauthorized modifications to software images or artifacts, such as Docker images, which can introduce vulnerabilities or malicious code into your environment. The impact of such tampering can be profound, potentially leading to unauthorized access, data breaches, and reliability issues within your system. To identify and exploit tampered images, several techniques can be employed. One effective method is to use specific security tools designed to scan for vulnerabilities in your container images and artifacts. For example, we can use Docker Bench for security to check for Docker image vulnerabilities. Here's a command to run Docker Bench. docker run -it-net host-pid host -usernens host-cap add audit can docker content trust equals docker content trust //css ro -v bin docker container d usr bin docker container ro v/bin docker run var run docker.sock var run docker.sock labeled docker.sock security docker/docker bench security. This command will help you to diagnose your Docker environment for potential security issues by checking the configurations and settings against industry best practices. Next, on slide 8, we'll explore supply chain attacks, where we'll define what they are, discuss their impact, and cover techniques for identifying and exploiting supply chain vulnerabilities. We'll also introduce KubeHunter as a tool for detecting vulnerabilities in Kubernetes clusters, illustrating it with an example. Stay tuned as we dive deeper into these critical areas of software security. On the previous slide, we discussed image and artifact tampering, including its definition, impacts, and techniques for identification and exploitation. We also walked through an example using Docker Bench to check for Docker image vulnerabilities. Now let's move on to slide 8, supply chain attacks. A supply chain attack occurs when cyber threats target the less secure elements of the supply chain to compromise an organization. These attacks can have a catastrophic impact because they exploit trusted connections and dependencies, leading to widespread breaches. To identify and mitigate supply chain vulnerabilities, it's crucial to monitor external dependencies, regularly audit the access and permissions third-party services have within your systems, and implement security practices like code signing and dependency management. For instance, we can use a tool like KubeHunter to detect vulnerabilities within Kubernetes clusters. By running kubehunter-remoteexample.com, we can scan and identify potential security issues in remote Kubernetes environments. This is essential for ensuring that the various components and services involved in your infrastructure are secure and trustworthy. In the next slide, we will delve into workload runtime attacks, looking at their definitions, impacts, techniques for mitigation, and how to monitor and secure runtime environments using cloud-native tools. As we move from supply chain attacks, covered in slide 8, let's now focus on workload runtime attacks, which are the topic of slide 9. First, let's define workload runtime attacks. These attacks target the processes and applications running within your cloud-native environments. The impact of such attacks can be severe, causing system downtimes, data breaches, and even full control over your workloads. To identify and exploit vulnerabilities in your runtime environment, there are several techniques you can employ. Monitoring is key, using cloud-native tools to keep an eye on unusual activities and configurations. Tools like Falco, for instance, can alert you when it detects anomalous behavior in your Kubernetes clusters. For our practical example, we'll discuss how to monitor and secure these runtime environments using cloud-native tools. This involves deploying monitoring solutions that provide real-time insights and automatically respond to threats. Next, we'll delve deeper into container escape attacks in slide 10, where we'll define what container escapes are, discuss their impact, and look at techniques to detect and mitigate such vulnerabilities. We'll also provide a practical example involving tools that can identify risks leading to container escapes. On this slide, we will be focusing on container escape. First, let's define what container escape attacks are. A container escape occurs when an attacker breaches the isolation mechanisms of a container, allowing them to access the underlying host system or other containers running on the same host. This could potentially lead to significant damage, as it can compromise not just the single container, but the entire host system and other containers. Next, we'll discuss techniques for identifying and exploiting these vulnerabilities. Potential vulnerabilities can often be found in misconfigured container settings, unpatched software, and inadequate runtime security policies. Attackers might exploit these weaknesses using various techniques such as privilege escalation, breaking out of the container through vulnerable software, or exploiting host kernel vulnerabilities. An example of detecting and addressing these vulnerabilities includes using tools like Docker Bench for security or Kubernetes Bench for security, which can help identify security issues in the container configuration and the underlying runtime. Additionally, continuous monitoring solutions can provide real-time alerts on any suspicious activity that might indicate an attempted container escape. In the next slide, we will delve into trust relationship abuse, exploring definitions, impacts, and mitigation techniques for this specific type of attack. On this slide, we're focusing on trust relationship abuse. In cloud environments, trust relationships typically form the foundation of how different services and resources interact with each other. These relationships are critical, but if not properly managed, they can become a significant security vulnerability. First, let's define trust relationship abuse. This occurs when an attacker exploits these relationships to gain unauthorized access or escalate their privileges within a cloud environment. The impact of this type of abuse can be extensive, leading to data breaches, unauthorized data manipulation, and even control over the entire cloud infrastructure. Next, we'll delve into techniques used to identify and exploit these vulnerabilities. Commonly, this involves analyzing the policies set for trust relationships, looking for misconfigurations, or overly permissive settings. Tools and methods such as automated scanning scripts or manual policy reviews are also frequently employed to unearth these weaknesses. As an example, we might test trust relationships in cloud environments using tools designed to evaluate the security postures of trust policies. We can simulate scenarios where an attacker might gain access through a compromised service or improperly configured role, observing how these relationships can be leveraged to escalate privileges or move laterally within the network. In the next slide, we'll provide an overview of various tools often used in cloud-based attacks, emphasizing the importance of selecting appropriate tools for each specific attack type. On this slide, we are going to delve into the tools used in cloud-based attacks. Understanding and selecting the right tools is crucial to effectively executing these types of attacks. Each tool has its strengths and specific use cases. Our main focus here will be on providing an overview of the available tools, key features, and understanding which tools work best for different types of cloud environments and attack vectors. This knowledge will allow you to choose the most appropriate tool for tasks such as identifying vulnerabilities, performing penetration tests, or exfiltrating data. In the next slide, we will go into more detail on one specific tool, PACU. We'll look at how PACU can be used in cloud-based attacks and provide an example of running PACU to assess an AWS environment, specifically utilizing the EC2 exfiltrate module. This will give you practical insights into applying what you've learned with the tools discussed in this overview. Slide 13 delves into PACU, a powerful open-source cloud penetration testing tool specifically designed to target AWS environments. First, we'll cover an overview of the PACU tool. PACU is tailored to exploit and perform security assessments on AWS services. Its modular architecture allows for flexibility and customization, making it suitable for a wide range of attack scenarios. Next, we'll discuss techniques for using PACU in cloud-based attacks. This includes setting up your environment, loading appropriate plugins or modules, and executing specific tasks such as privilege escalation, data exfiltration, or service discovery. For a practical example, let's consider running PACU to assess an AWS environment. Here, we'll demonstrate how to execute the PACU run E2 exfiltrate command. This specific command module is designed to exfiltrate data from EC2 instances, showcasing how PACU can be effectively used to evaluate the security posture of EC2 components in your AWS setup. By mastering the use of PACU, you will be better equipped to identify vulnerabilities and weaknesses within your AWS cloud infrastructure, providing invaluable insights for improving your overall security measures. In the next slide, we will discuss another essential tool, Docker Bench, which is pivotal for container security assessments. On slide 14, we're shifting our focus to another essential security tool named Docker Bench. Docker Bench is a comprehensive security checker for Docker containers, designed to help ensure that your containerized environments are following security best practices. First, let's dive into an overview of what Docker Bench offers. This tool runs various checks to evaluate the configuration and security of your Docker environment. It assesses numerous areas like Docker daemon configuration, container images, and container runtime. Ensuring your Docker setup adheres to best practices helps minimize vulnerabilities that could be exploited in cloud-based attacks. Next, we'll consider some techniques for using Docker Bench efficiently within cloud environments. By integrating Docker Bench into your CI/CD pipeline, you can automate security checks for your containers, ensuring that each build meets the necessary security standards before deployment. Regular scanning is critical to quickly identifying and mitigating potential security risks. Now let's go through an example of how to run Docker Bench to audit your container security. bash docker run itnet host dash pid host dash userends host cap add audit control docker content trust mcro nash v use slag docker container dash slash usr bin docker container row dash v you add bin docker run dash nash v dash live var run docker.sock label docker bench sock docker bench security. This command initiates Docker Bench with the appropriate privileges and mounts necessary directories in read-only mode to ensure a thorough security check without altering the environment. On the next slide, we will delve into another essential security tool called KubeHunter, which focuses on identifying vulnerabilities in Kubernetes clusters. Continuing from where we left off with Docker Bench, let's now shift our focus to another critical security tool, KubeHunter. KubeHunter is designed specifically for Kubernetes clusters. This tool performs security assessments by hunting for potential vulnerabilities that could be exploited within your Kubernetes environment. Much like Docker Bench, KubeHunter is useful in cloud-based security assessments. You can deploy KubeHunter to scan your Kubernetes cluster, either locally or remotely, to identify weaknesses and mitigate risks. For example, running KubeHunter is straightforward. You can execute it with the following command to scan a Kubernetes cluster remotely: kube-hunter remote-example.com. In this example, KubeHunter initiates a scan of the Kubernetes cluster hosted at example.com, looking for security gaps and possible vulnerabilities that may be present. In the next slide, we will delve into Prowler, another indispensable tool for performing extensive security assessments, but this time specifically targeting AWS environments. Continuing from our discussion on cloud security tools, let's dive into the next tool, Prowler. So slide 16 focuses on the Prowler tool, which is an extensively used open-source security assessment tool designed for AWS environments. First, let's go over an overview of Prowler. Prowler is a command-line tool that helps ensure your AWS cloud infrastructure is aligned with security best practices. It works by running a variety of checks against your AWS account, spanning areas like identity and access management, IAM, logging, monitoring, networking, and all the crucial security aspects. Then we move on to some techniques for using Prowler in cloud-based attacks. In penetration testing or red teaming scenarios, Prowler can help identify misconfigurations, weak security settings, and potential vulnerabilities within your AWS setup. For example, Prowler can reveal IAM policies allowing excessive permissions that attackers might exploit. Finally, let's see an example of using Prowler to perform AWS security assessments. The command prowler-call is used to run a comprehensive security check covering all available controls. This command initiates a scan of your AWS account and provides a detailed report with findings categorized into high, medium, and low-risk issues. In the next slide, we'll look at another powerful security assessment tool called Scout Suite, which can be used not only with AWS, but also Azure and GCP environments. Now, let's move on to Scout Suite. Scout Suite is another powerful tool you can use for assessing the security of your cloud environments. It's a multi-cloud security auditing tool that works with AWS, Azure, and GCP. Just like Prowler, it helps you discover and mitigate potential security risks, but it has the added benefit of supporting multiple cloud providers. When using Scout Suite, there are various techniques and strategies you can employ for cloud-based attacks and security assessments. This tool gives you a comprehensive view of your security posture by pulling in and analyzing your cloud configuration and services. For example, to assess an AWS environment, you would use the command shell scout AWS region US East 1. This command targets the specific AWS region US East-1 and generates a detailed report of any potential vulnerabilities or misconfigurations you may need to address. In our next slide, we'll delve into cloud-native vendor tools, comparing their features and discussing how they can be leveraged for security monitoring and assessments. Let's move forward to see how you can use AWS Trusted Advisor for security checks. In the previous slide, we discussed Scout Suite, an excellent tool for auditing your cloud environments across AWS, Azure, and GCP. We explored the techniques for using Scout Suite in cloud-based attacks and demonstrated a command example for assessing an AWS environment. Now let's shift our focus to slide 18. which covers cloud-native vendor tools. These tools are provided by the cloud service providers themselves and are essential for security and monitoring within your cloud infrastructure. First, we'll take an overview of these vendor-provided tools. These tools, such as AWS Trusted Advisor, Azure Security Center, and Google Cloud Security Command Center, are designed to help you keep an eye on the security posture of your cloud environment. Next, we'll look into techniques for leveraging these cloud-native vendor tools for conducting cloud-based attacks. These techniques can help you identify configuration issues, compliance gaps, and other vulnerabilities that could be exploited. For instance, using AWS Trusted Advisor can help you perform a security check to identify the potential risks in your AWS environment. By analyzing the recommendations provided by Trusted Advisor, you can prioritize and mitigate any identified security vulnerabilities. In summary, using cloud-native vendor tools is a critical component in understanding your cloud environment's security landscape and effectively conducting penetration testing. In the next slide, we'll wrap things up with a conclusion and review of the cloud-based attack techniques and tools we've covered throughout the course. We'll also discuss the importance of practicing these techniques and provide guidance on next steps and further learning opportunities. Before we wrap up, let's quickly review what we've covered. We discussed various cloud-native vendor tools and how they can be employed in cloud-based attacks, with a specific example of using AWS Trusted Advisor for security checks. Now, on this final slide, we're summarizing the key cloud-based attack techniques and tools we've explored throughout the course. We emphasize the importance of practicing and mastering these techniques to be effective in penetration testing. As for the next steps, I encourage you to continue your learning journey by exploring additional resources and advanced topics to further sharpen your skills in cloud security and penetration testing.